Hello, this is mathjazz from Almost Cool. I'm here with the Mathemagician, and we are continuing work on the western wall of the Taj Mahal complex.
Hello, everyone.
So, let's see. Oh, it's already tall enough that I can't get up there without help.
G ladders.
I think I put ladders on the north end here.
There are, but I was just going to drop them down to you from here.
Go.
So the next bit, I guess this still needs to go up another layer, but then on top of that goes a triangle. So 1, 2, 3. Back up a little bit. There you go. And then 3 like that. And that finishes off the inside part.
Okay. Do you want me to run
And then
down and put triangles on all of these?
yeah. So build it up. So it needs to go up one more full thing and then the triangle. Yeah.
All the way down to the corner?
I think so. Let me double check for you. Yeah, all the way down to that circular area. There is a circular area down there, right?
Yeah, it's in the corner.
Okay. Yep. I couldn't remember if I had built it up when I was making the framework or not.
Okay, I need to get this brown hardened clay. Need anything from the supply chests?
What was that?
Do you need anything from the supply chests? Because I just ran out of
Oh,
brown hardened clay.
I don't believe so. I think I'm good. Okay, I gotta hop off for just a second. I shall return.
Well, everyone, I am going to dye a whole bunch of clay brown so that I can continue this wall. So, this week I am working on my spectral analysis, spectral sequences class, which is a class about rings that have some extra structure on them, maybe modules a little bit as well. And if you don't know what those are, well, someday I'll get around to making a video about rings and modules. Probably several videos about rings and modules. But that said, that is the big class that I'm taking this semester, and that is over. Then I will have more free time to do more work on the math videos that I actually started this channel to show calculus videos and not. My goals for this summer are to start making videos for the finite math class that I was asked to teach, to help the students from that class this next semester. And then I also want to go back and make videos on integrals, the second half of calculus of a single variable. And the third thing I want to do, I think that actually this might be the thing that I'm most interested in doing right now. I want to start doing research level math, or at least graduate level mathematics on this channel. I want to, there are some really great channels for learning math. Khan Academy does everything up to about differential equations, so like everything an engineer might need to know about math. But it doesn't go into kind of the pure theoretical math that that mathematicians actually do for work. And Numberphile does some theoretical math, but it doesn't do it very rigorously. Like it's more of a sensationalized channel, I guess. No, it tries to talk about I guess the way to best put it is Numberphile has a video that says that the sum of all of the positive integers is negative 1/12. And I mean, in a sense, yeah, using a very specialized tool called an analytic completion. Yeah, sure, why not? It's negative 1/12. But the thing is that they kind of have a habit of talking about things that are non-standard as if they were standard. Mostly, I think, out of shock value. Oh, not only is this infinite sum of positive numbers that increase, not only does it add up to a finite number, but it adds up to a negative finite number. Like, well, only in this one particular special situation. But sure, why not? I guess what I mean is, like, we build our mathematics to represent the world, and we can create all kinds of hypothetical mathematics systems. that all have these different properties. But then when we try and solve a real world problem, we have to figure out, well, which of these models is the right model? Well, how about we talk about geometry, for instance? We talk about triangles have 180 degrees of angle measure to them. Sure, that is a perfectly valid geometry, but there are other planar geometries out there where triangles have more or less angle than 180 degrees, and this depends on how big the triangle is. In a spherical geometry, the bigger your triangle is, the more the angle measure of the triangle will be, and all triangles have angle measure bigger than 180. Hyperbolic triangles, it's the opposite. The bigger your triangle is, less your angle sum will be, with all of these triangles having at most 180 degrees. And you think, well, like, sure, we can develop these three different types of geometries that have these three different types of triangles and all of these things, but why, obviously in the real world, triangles have 100 degrees. Well, not really. It depends on what you're doing. In the real world, on planet Earth is kind of spherical. It's an oblate spheroid. It's the usual term used for it. It's round like a ball. And the thing is that when you draw triangles on a round object like a ball, then they have angle measure greater than 180. So talking about what happens in the real world, well, the fact is that in the real world, if you started at the North Pole and you walked, a quarter of the way around the Earth going south, pick your favorite south, because there are a bunch of them when you're standing at the North Pole. But you continue in a straight line, quarter of the way around the Earth, and then made a 90-degree turn to your right, and went a quarter of the way around the Earth, and took a 90-degree turn, and went, a 90-degree turn to the right, and took a quarter of the distance around the Earth. You just traveled three quarters of the distance around the Earth, and you made three 90-degree angles, and you end up back at the North Pole. You can try it with like a basketball or some other ball if you want to. But you just made a triangle because it has 3 points and 3 edges, and they all connect. But that triangle has every angle on it as 90 degrees. And you think, well, how does this happen? And the answer is that planar geometry is not the right tool for analyzing triangles on a sphere like the Earth. Or, Earth is close enough to a sphere for most purposes. So, getting back to the problem, Numberphile says that sum of 1, 2, 3, 4, all the way up to infinity is negative 1/12. Well, only in one particular branch of mathematics, it's kind of like saying that all triangles have 180 degrees, except it's more like saying all triangles have less than 180 degrees, because it's not the standard, the normal, usual way of adding an infinite list of numbers. It's not the normal, usual way that goes. Numberphile took the strange way and decided to use that as their example of infinite sums. So that's kind of the thing with Numberphile. The other thing with Numberphile is that they don't talk about any of the proofs. And proofs are important, because the power of mathematics is not just that we say, oh, this is an answer. It's that we can say this is the right answer, and here are the reasons why it's the right answer. And so when you omit all of the proofs, then you're actually losing like the most useful, beautiful, interesting part of math is that things aren't based on, being rhetorically interesting or being aesthetic in any sense other than um, having an aesthetic in its austere logic. Oh, anyway, Mathemagician came back. So,
Oh,
what did you
so
think about my rant?
I only caught part of it, but yes, triangles on the Earth completely fail the triangles angle sum formula from high school geometry.
So, yeah, that was my talking point, but my main point was about the YouTube channel Numberphile, saying that you Numberphile is a great channel, but what I want to do is I want to have videos with rigorous proofs of mathematics, particularly of like graduate level advanced mathematics, because I find that that's lacking on YouTube. You have I compared my channel to Khan Academy and the goal of my channel to Khan Academy, which is very rigorous and has wonderful resources showing a bunch of proofs and showing a bunch of solved problems. But the problem is that Khan Academy stops with with differential equations, which is a perfectly beautiful class, I'm sure. But it's not research math; it's engineering math.
Yeah.
And then on the other hand, you have you have Numberphile, which shows interesting theoretical results and talks to like research mathematicians and asks them about their work. But the problem is that in trying to appeal to a wide audience, they don't actually rigorously prove much. It's and not only that, but they sensationalize a lot of the time, uh, taking very unique and specialized branches of mathematics and treating all of mathematics like it's a specialized branch.
Uh,
For example, have you seen their video about how the infinite sum of integers from 1 to infinity, positive
mm,
integers, natural numbers, is negative 1/12th?
I have not, but I have heard people reference it quite a few times.
And it's great that it's causing this discussion. It is a very, Numberphile makes great videos. Like, they have talent in writing and editing that I hope to develop someday. I'm not trying to knock either of these channels. Um, I'm just hoping that through practice, I I can carve out my own niche in YouTube, which would be videos that are very rigorous proofs of advanced mathematics. Because I think that YouTube doesn't really have that yet.
Yeah.
Do I just continue these white bands and brown centers all the way down?
Uh-huh. Yeah, I
Wonderful.
jumped down here to light stuff up as we are kind of closing this off so that we don't get loads of mobs.
That's a good thing.
Because I don't know if you noticed, but we had a spider that was coming after us and a creeper chilling at the bottom.
Oh, I didn't notice. It's a good thing you did.
Okay. Perfect. Excellent, excellent, excellent. Can I close off this little staircase of brown clay?
Do we have other ways of getting up here?
We have ladders on the other side.
Okay.
So
Yeah, if we have another way up, then that's fine.
yeah, I guess though if we were to fall onto the inside, it would be a pain to get out. So let's wait till we have this sealed off, and then we can do that. Good point.
Well, it is that time again. So,
Okay. Bye, YouTube.
bye, YouTube. Have a great day, and we will see you next time.